Okay, so you have seen how to calculate the work done for a reversible adiabatic process. Now, we are going to talk today about how one can calculate the work done for a irreversible adiabatic process, and then we will compare the work done in an irreversible and reversible manner for for adiabatic processes and see that which work is more and which is less, given that the final pressure is same for all the processes. So, now we have already discussed that for a PV diagram, let us say our initial point is P 1 V 1 at this point, and then let us say the final point is somewhere P 2, and I draw that by this line. This is P 1 pressure and this is final pressure is P 2, that is drawn by the line dash line. Now, if the process is carried out in an isothermal manner, you know the final volume will be much more, such that the work done is more than a corresponding reversible adiabatic process. So, let us say this is isothermal reversible process and this is adiabatic reversible process. Now, we would like to know that what will be the work done for an irreversible adiabatic process, given that the pressure final pressure is P 2 as that in the reversible process as well. So, let us say that for a reversible process the final volume is V 2, but for an irreversible process let us say the final volume is V 2 prime. So, then we know from the formula of work done in an adiabatic process is it is C V dt or C V delta T, or let us say the final temperature for a reversible adiabatic process is T 2 and initial temperature let us take as T 1. So, let us say initial point is P 1, T 1 and V 1, and it is going to V 2 and T 2 for reversible process. So, let us say P 1, V 1 and T 1 to P 2, V 2 and T 2 for a reversible adiabatic process, and it is going to same pressure, same final pressure, but maybe a different volume V 2 prime and different temperature T 2 prime in irreversible adiabatic process. So, we are going to calculate the work done in both, and you are going to see that which work done is more and which is less. Although we already know that the work done for an isothermal reversible process is more than that of an adiabatic process, and also we have shown that an irreversible process in isothermal process has less work done by the system is less than work done by the system when the process is reversible in an isothermal case. We are going to compare here only the adiabatic case. Okay. So, let us first start with the calculation of adiabatic work done, and we know that adiabatic irreversible work done. So, let us write that adiabatic irreversible work done will be C V T 2 prime minus T 1 prime, which is again of course same as minus P 2, which is a final pressure, and the volume is V 2 prime minus V 1. Now, if we write down the equation, it will be C V T 2 prime minus C V T 1 equal to minus P 2 V 2 prime plus P 2 V 1, and then we rearrange the equation. We will write C V T 2 prime plus P 2 V 2 prime is equal to C V T 1 plus P 2 V 1. Now, we know that from ideal gas equation of state that P 1 V 1 equal to N R T 1, P 2 V 2 prime will be N R T 2 prime. So, you can write C V T 2 prime plus N R T 2 prime is equal to C V T 1 plus P 2 V 1. So, we can take T 2 prime common and write C V plus N R is equal to C V T 1 plus P2 V1. Now, we know that Cv plus Nr is Cp. So, or T2 prime is Cv T1 plus P2 V1 by Cp. So, we got our final temperature T2 prime for an irreversible adiabatic process. Now, let us calculate the work done. An adiabatic irreversible process will be Cv T2 prime minus T1, which will be the same for again the reversible adiabatic process as well, but in case of reversible adiabatic process the temperature itself will be different final temperature when the pressures are same between reversible and irreversible processes. So, let us do that then. So, Cv, now I will put the equation 1 in equation 2 and write that Cv T1 plus P2 V1 by Cp minus T1 Cv by Cp, Cv T1 plus P2 V1 minus Cp T1, and Cv by Cp will be 1 by gamma, and it will get P2 V1 minus, and we know Cp minus Cv is Nr. So, we will get Nr T1. Now, again using ideal gas equation of state we can get Nr T1 is P1 V1. So, we get P1 V1. So, now this is the work done for an irreversible adiabatic process. Let us compare that with a reversible adiabatic process. So, work done for a reversible adiabatic process is again Cv T2 minus T1. Remember, the pressure is same P2 between reversible and irreversible processes. However, the temperature may or may not be different. So, we designated that by T2 for reversible and T2 prime by irreversible processes, and then converted everything in terms of known quantities. For example, P1 V1 is known because that is the initial state, and P2 is also known. So, therefore, and gamma is also known. So, therefore, we have converted that way. Now, let us see what we get from this. Now, Cv T2 minus T1, we can say that T2 is, again we can use ideal gas equation of state and write T2 as P2 V2. So, you know PV equal to nRT, right. So, by Nr minus P1 V1 by Nr. Now, Nr I can take it out and I can write Cv by Nr and then write P2 V2 minus P1 V1. Now, what is Nr Cv by Nr? So, we know that Cp minus Cv is equal to Nr. So, if I divide by Cv both sides, then I will get Cp minus Cv by Cv equal to Nr by Cv. So, which means 1 minus 1 by gamma is Nr by Cv, or let us say just back up this step and we write, we can invert that and we want Cv by Nr, right. So, we can do the inverse of that and we can write Cp minus Cv is Nr, we know, we have to divide by Cv. So, it should be Cv, correct. So, Cp minus Cv by Cv equal to Nr by Cv, and which means that it is Cp by Cv minus 1 equal to Nr by Cv, or gamma minus 1 equal to Nr by Cv. So, Cv by Nr is 1 by gamma minus 1 P2 V2 minus P1 V1. Now, we got the expressions for reversible adiabatic process and irreversible adiabatic process. Now, let us compare between them and see which is more and which is less. Now, once we compare that, we see that, let us start with irreversible adiabatic process. Now, we see that irreversible adiabatic process is 1 by gamma P2 V1 minus P1 V1. Now, if I replace V1 by V2, since the V 2 is larger in volume, that will be a bigger quantity. So, we can write 1 by gamma P 2 V 2 minus P 1 V 1 is greater than the irreversible adiabatic work done. Now, we can replace gamma by gamma minus 1, which will increase it further. So, we can write 1 by gamma minus 1 P 2 V 2 minus P 1 V 1 is larger than 1 by gamma P 2 V 2 minus P 1 V 1, which is larger than adiabatic irreversible process. Now, you see, compare that with the above expression from equation number 2. So, this is same as equation number 2, and so therefore, this is same as work done in a reversible process. So, therefore, work done in a reversible process is greater than work done in irreversible process, given that both the processes reach the final pressure, and this is true only for the expansion process. Why? Because we have already assumed that V 2 is larger than V 1. So, we are only talking about an expansion work. So, only for the expansion work in a reversible process, adiabatic work done will be greater than work done in an irreversible process. And we know it is C V T 2 minus T 1 will be greater than C V T 2 prime minus T 1, which means T 2 will be greater than T 2 prime. So, the temperature will be lowered more in case of adiabatic processes, and therefore, we can say that final volume V 2 that will be obtained in a reversible process will be, because we know that V is proportional to T, right, because P V equal to nRT. So, V is proportional to T. When the pressure is constant, then V 2 will be more than V 2 prime. So, the volume also will be more, final volume will be more in case of a reversible process than an irreversible process. So, starting with P 1 V 1, let us say if you reach a volume V 2, then the adiabatic volume will be somewhat less than that, it will be P 2 V 2 prime, and the work done for an adiabatic process in an irreversible way will be this much, whereas work done for an adiabatic reversible process will be that much. Okay. So, that is where we stop.